Today, we shall look at the topic quadratic graphs. In order for us not to waste all the time in explanation, it will be proper to look at examples. Let's take the first example. I believe that the student will be able to follow up by examples. Alright, in the graph above, find the roots of the equation y is equal to f of x, and which is equal to 0. The answer to this are x is equal to, you take this is the root of the equation, and so it's equal to 2, and x is equal to, the other root of the equation is the mark represented by 8, which is 8. Alright, let's take another example. Alright, let's look at these instance. Here we have a graph, a quadratic graph. Let's say this is the y-axis, this is the z, this is the x-axis. Now the question requires us to do something. Now the question says, what are the roots of the quadratic equation? Ax squared plus bx plus c is equal to 0. How do we get the roots? Now from the graph, we understand that the roots can be found by tracing the mark where the curve cuts the x-axis. And so if we trace it down, if we trace the curve, we observe that it cuts the x-axis at a particular mark. And let's say that at that mark, let's echo it and call it x is equals to, since the mark is between -2 and -1, we may say that it is approximately -1.5. And we continue with the curve. Now as we get to the mark 1, we observe that this curve cuts the x-axis at this mark 1. And so we say that x is equal to 1. Therefore, the roots of this equation, whose graph is given, are s is equal to -1.5 and s is equal to what? Equals to 1. Alright, let's take a third example. Alright, let's look at the quadratic graph above. This is an example. Here we observe that the graph curves downward and then reaches a minimum and then begin to rise upward. Alright, the answer to this question is very simple. We have been told to find the minimum value of what? Of y. Now this is the y-axis, while this is the x-axis. To find the minimum value of y, what we have to do is to find the point is to find the turning point of this curve, or to find the stationary point of this curve, or to find the gradient of the curve, the gradient of the curve. That is to find the point where the gradient of the curve is equal to 0. So to do so, we find the lowest point here, which is the point the point dotted here. Alright. Now the lowest value of y, or the minimum value of y, or the least value of y is y minimum is equal to, you trace this point towards the vertical line, which is the y-axis. Then when we get to this point, we observe that it reads minus 16. So we write minus 16. So here then, we say that the minimum value of y is equals to minus 16. Let's take the last example. Alright, let's look at the example carefully. Here we have another curve. So we say in the graph above, find the maximum value of y. The answer to this is not far-fetched. We write y maximum, which means it is the maximum value we are looking for. Here we see that the curve rises until you get to the maximum point. We call it the maximum point. Then after the point, the curves begin to fall down. Alright, so the point, the maximum point is the point here. And this is the stationary point. This is also the turning point. Or it is a point where the gradient is 0. Now, to find the maximum value of y, we trace this point until we get to the vertical line, which is the y-axis. And then the number there is what? Is 10. And so we write 10. Now the student should take the following drill. Now this is a parabola. The quadratic graph is a parabola. Alright, the drill says, in the graph above, determine the roots of the equation f of s is equal to 0, and then the maximum value of y.